This video covers how to calculate rainfall for a specific watershed, called Areal averaging. You are given the following watershed with 6 gauges. Some gauges are internal and some are external. However, all contribute to the rainfall characteristics within the watershed. The first method, the station average method, is by far the simplest in concept. It requires the rainfall at the working gauges for a specific storm are within 10% of each other, meaning only a 10% variability in total rainfall. The equation states that the watershed rainfall is equal to the average for all the gauges. The following equation helps visualize how to calculate the rainfall for the schematic shown. The next method is the Hiatt Method. The following schematic shows a watershed superimposed on an Hiatt map. The equation states that the watershed rainfall is equal to a weighted area average. In order to calculate each area, you must measure the area of each of these divided areas, as shown in the movie. There's a total of 5 areas. By summing each of the 5 areas, you will determine the total watershed area. Next, you need to determine the precipitation for each of the areas, which is determined by taking an interpolated average, as shown. Next, the following equation will help visualize how to calculate the rainfall for the schematic shown. The third method and final method is the Thiessen Polygon method. The equation is the same as for the Hiatt map. It is based on a weighted area average. The following schematic will help outline the Thiessen Polygon method. You're given a watershed, and there are 4 gauges that contribute to the rainfall characteristics of this watershed. First, we need to identify the watershed. Next, you need to connect all the gauges in a clockwise direction with a dashed line as shown. Next, connect all internal gauges to each other. On occasion, there may only be one internal gauge. It is not required, but at times you may need to connect the internal gauges to additional external gauges in order to create delineated areas. But for this example, you will not have to. Next, find the midpoints for each of the dashed line, as shown with the purple dots. Next, draw perpendicular lines to the dashed lines at the midpoints for the watershed boundary to where the lines intersect, as shown. Area AB and AD, area AA and AC. Finally, you can calculate the average rainfall for this watershed by multiplying the precipitation for each area at the gauge times the area and then dividing it by the total area. For class, please complete the following example located within your handout.